Today I'm going to go over 9.5, comparing sets of data. So this will follow with what we did last time. Comparing distributions. When we're comparing two sets of data, if the distributions are both symmetric, we're going to use the mean and standard deviations to compare the data. If they are not symmetric, then we are going to be using the 5-number summary. So let's dive into an example. We have two attendance for the PTSA meetings at 2 elementary schools. So we're going to go ahead and enter both of these data into the calculator at the same time. So I'm going to go ahead and we're going to do stat edit. I'm going to clear any list that I have, and then we're going to enter in the data into L1. And in L2, we'll do the second one. So 76, 63, 57. Okay. So we're going to look at if the data is symmetric or not. So I'm going to go to stat plot. I'm going to go ahead and do a box and whisker. So in our first one, I want this to be a box and whisker. And then I'm going to go back to second stat plot and go to plot 2, turn that on, and we want list 2. If list 2 isn't in there automatically, you go to the number 2 button. Above it is L2, so we do second L2. Then I'm going to do a zoom stat. Okay, so those are our datas. This one is positively skewed. This one is negatively skewed. So since they're both skewed, we're going to use the 5-number summary. Which from the box and whisker plot is really easy. So for Rocky Run, okay, I'm going to go ahead and do its 5-number summary. We're going to trace, it's going to be this top one, and fill in the values. So the minimum is 20, 26, median's 32, 43, and 56. Then we'll repeat this for Trailwood. Okay, and we'll just hit the down arrow to trace on this second box and whisker. So we have a minimum of 28. Q1 is 45. Median is 60. Q3 is 68. And our maximum is 32. I should say Q3. Okay. Sorry, I realized I just answered. This is our answer for part B. So we decided it is skewed, and then we used our 5-number summary to describe it. So there's an example on the back. Go ahead and try that one. Okay, so we have 50-yard freestyle times for when she was a sophomore and when she was a junior. Okay, when we graph it, they're both quite symmetric. So we're going to use the mean and the standard deviation. So I did the mean and the standard deviation for sophomore year, which was higher. So mean was 26, standard deviation was 0.8. For junior year, the mean is 24.3 and the standard deviation is 0.45. So that means her junior times are lower, and the spread is much less. So, and we can see that in the box and whisker plots. So that is how we can compare sets of data.